that space turns into time, time turns into space, and you could literally go forwards in time until you come backwards in time.
In this zoo, there is a place for almost everything, even a pizza.
Now you might wonder what pizza has to do with physics.
Richard Gott brought two very disparate parts of the universe together, pizzas and time machines.
This is time travel to the past. This is a time machine.
It all started when physicists all over the world began investigating a curious phenomenon.
In the mid-1980s, people became interested in cosmic strings. These were, I brought one here. These were thin strands of energy left over after the Big Bang that were predicted in about half the theories of particle physics at the time. They were narrower than an atomic nucleus. They had no ends, so either they were infinite in extent or they were large loops. These might be millions or billions of light years across, but very, very thin.
Perhaps, and perhaps not. In fact, cosmic strings have never been observed in the real world. They're entirely theoretical. They're mathematical inventions. So imaginary, in fact, that no one could find a way to describe them completely. Gott made his name by solving that particular problem.
I was quite excited to find this solution, and it was important to have an exact solution because it gives us a way to look for the cosmic strings.
His solution showed that space and time round a cosmic string were very strange indeed. And now he wondered what would happen with an even more exotic phenomenon: two cosmic strings passing in the night.
Years later, I found a solution for two moving cosmic strings. And here's, if you have two moving cosmic strings that are moving by each other, what does that solution look like?
Gott's mathematical equations predict that two cosmic strings would twist time out of shape completely. There would be a loop in time, just like the one in Tipler's cylinder.
If the cosmic strings moved rapidly enough, but still slower than the speed of light. The solution was sufficiently twisted so that you could start here, circle the two cosmic strings while they were passing, and come back to an event in your own past.
And if that's not entirely clear, then here comes the pizza again.
Wonder what pizza has to do with physics. Well, if you wondered what the space around a cosmic string might look like, you might think that the string would come down through the center and the space around it would look like just a regular pizza. But actually, my solution, surprisingly, showed that it looked like a pizza with a slice missing. So I'm just going to cut out a slice here and get rid of it. You can eat it if you like. And then you fold the pizza up to make a cone. And the circumference around the string is less than you might think. So this is what the geometry around a single cosmic string looks like. So if there's a second string here, you take out a second slice of pizza here. And then this is folded up on both sides. It looks kind of like a paper boat. Now, how does this make a time machine? Well, suppose you're living over here on planet A. You get a spaceship. You could send a light signal to a friend of yours on planet B, go right through between the two cosmic strings. But you could get in your spaceship, and by jumping across this missing pizza slice, you could take a shortcut and get to planet B quicker than the light beam. You can leave planet B at noon here and travel over here and arrive back at planet A at noon. In fact, you can arrive back in time to shake hands with your younger self and wish yourself a nice trip around the cosmic string.
So that's a time machine?
So that makes a time machine.
Richard Gott's proposal is only the latest suggestion for how a time machine might work. There are now many solutions which claim to allow an astronaut to go in both directions in time. Unfortunately, though, they all suffer from a common flaw. The only society that would be clever enough to try and build such machines lies thousands of years in the future.
A civilization that has galactic power, that can play with star systems and black holes, they would be masters of space and time. However, the energy necessary to drive a time machine is far beyond anything that can be harnessed by people on the planet Earth.
The time machine that I proposed using cosmic strings, if you made that out of a loop of cosmic string and wanted to go back in time about a year, take half the mass of our galaxy, take a loop that big.
And even if someone did manage to build these machines, they'd be of limited appeal. For they all rely on creating loops in time. And it's now been realized that loops in time have a rigid rule of their own.
All of the methods that have been discussed so far, whether it's Gott's cosmic strings or spinning black holes or any of these things, all share the property that you can't go back in time to before the time machine was built. So if someone builds one in the year 3000, they can't come back and tell us about it. We can't build a time machine now and go back and see the dinosaurs, unless, of course, some friendly aliens across the galaxy have made one hundreds of millions of years ago and would lend it to us.
Exterminate! Exterminate!
You might have thought all this meant the whole idea of time travel had come to nothing. But you'd have reckoned without the imagination of physicists. The quest for a way to master time was about to lead to the darkest conclusion of all. Around 5 years ago, a group of scientists and philosophers began arguing there might be another way to travel in time. But it wasn't a machine in space, and it wouldn't involve moving galaxies around. It would be a computer. And the pioneer of this unlikely approach was that unlikely pioneer of time machines, Professor Frank Tipler. From the 1970s, he'd been excited by a trend in computers.
People realized that processing speed of computers was increasing exponentially. Every year, every few years, every 18 months, the processing speed would double.
If this trend was to continue unabated, it would mean computers would get ever faster and ever more powerful. So much so